Hey class, let's do a quick recording of how we're gonna program our first program, which is generating element stiffness matrix (EK) for a 2D truss member or element, whatever you want to call it. Okay, it's quite simple. I mean, you just go to your folder, working folder, whatever it is. Yeah. For example, we say this here. Make sure you're in there. And then you just do the new script. You're like, oh, not a script, it's a function. Yeah, I know, it's a function. Okay, the function, if you take all my former MATLAB basics training things, the function and script editor, they are the same. The only difference is for function, you just need to do function. Okay, the MATLAB knows you're doing function, so it turns blue. Then you want to output. So this will be the element stiffness matrix you're going to output. But typically I always do my function with result, res, or yeah, you can call it R, or, yeah, just give it a name. Like those three letters doesn't really matter when you call it. Then the function name, yeah, you know, just like a baby's name, you want to be a little bit careful here. But whatever you want, but you need to be able to remember it. The bad thing is that you can't do 2D because MATLAB don't allow you to start a file with numbers at the front. So typically I just do truss, yeah, in fact, you know what, truss 2D, something like that. You know, it's a truss member, it's a 2D, and then, oh, of course, you want to do the EK, element stiffness matrix of truss 2D. That's pretty straightforward. Now, a lot of things, like what's your input? What do you need to know? Like I said, the EK is only decided by the geometry and by the material property. So you have to input that. Geometry, if you think about it, like we talked earlier in the class, you can do the length and angle and everything, but really when you're in this class, think about everything like the first thing we do when we do anything is to establish a coordinate system. There's a cleverer or more elegant way to input geometry, like length, stuff like that, is by inputting the coordinates of your node. So you can do x and y for load I and x, y for load j. So you can do just x1, y1, x2, and y2. Okay, then you do your area, and then you do your elastic modulus. Then you're like, where's the theta and the L? Well, you got x and y for your two nodes. You should be able to calculate that inside your function. Now notice that everything is kind of marked by MATLAB because we haven't using it yet. If you just do there, it'll just say might be unset, which simply means it's not used. So you come here, and then of course you're gonna just say, okay, this is just little note to yourself to generate EK for 2D truss member. Yeah, you can put more in there, whatever you want, just followed by this. But yeah, you don't need to. You don't have to. This is quite simple. So you're like, how am I going to do it? In fact, the first thing to do is actually just go back to your notes, look at the sine and cosine. Maybe you just say big C equals to cosine of our theta then you're like, hey, hold on a second, you're not doing theta yet. Yeah, I know, but this is how I like to program it. So basically, you just copy your notes, then figure out it from the backend. S is sine theta. Yep. Cosine and sine, there are MATLAB functions. And of course, the MATLAB is going to say, yeah, what the hell is theta? You don't know. So we're going to calculate it later on, but we'll put it there so that to make our life easier. So we'll say our EK, right, equals to E times A. Oh, come on, what am I doing? A times E, or whatever, divided by the length, L. And then times, then just, copy the notes. C square, and then S times C, negative C square, negative S times C. Yeah, nothing fancy, just copy the notes. Okay, if you want to make it nicer, yeah, actually it doesn't really matter. You can do something like this, and then yeah, this one's actually square. A lot of people when they type those type of things, they made mistakes. Don't, okay? If they're a typo, then it's really a pain in the ass. So don't do that. Come on. Just check everything clearly. Make sure you are typing exactly what the notes get to you. I think I can do something like this. Let me take a look. Okay, so this should be negative. This should be negative. This should be positive. This should be this should be positive, and then this should be negative. This should be negative. This should be positive. This should be positive, and then I basically close it out, and then I silence it, so I don't want this to print out every time. And then we got our EK, right? All you need to do now is to output EK. Remember, nothing get out of the function unless you assign to this guy. So we'll just say res equals to EK. Done. Okay. But yeah, if you're clever, you know we're not done. First of all, we haven't used those guys yet. Second of all, I mean A and E, they're okay. But we don't know what's L and what's theta. Okay, so here's how we do L. I mean, you all know what's L. L is just square root of x2 minus x1 squared. It's basic geometry, right? It's a triangle. Squared plus y2 minus y1 squared. You just go ahead and do that. Then how about theta? Yes, theta is kind of interesting. Because it's hard to actually direct calculate it. Because you can use the inverse of sine, cosine, or whatever, and calculate it based on L and x2 minus x1 and all that type of stuff. But because the sine and cosine functions, the inverse functions are not unique. You need to know which coordinate half of the plane you are at, and all that type of stuff. So it is actually easier to, I mean, don't get me wrong, you can do a program to calculate theta and then do this, or you can calculate cosine, sine directly. I'll show you how to do that. So we're not going to do this. You can do that, but you can actually use coordinates to calc C and S directly, and then this way the sign convention will always be right, and it will always be x1 to x2. So x1 is the I node, x2 is the J node. Yep. Then, so this is actually quite simple. You got L, right? L, and then something divided by L. Cosine. Cosine is kind of in the middle, so it's it should just simply be x2 minus x1. Oh, come on. That's it. And then it doesn't matter where your load I and load J is. This guy, if you input it based on your coordinate system as it is, it will take care of the signs of cosine. The L, it's a square root. It's always positive. Then for sine, yeah, you know the drill. y2 minus y1 divided by L. Done. Then you save it, and then it'll just fill that name for you. Then just do it. Then you're done. You got your truss2D. Let's try it out. So your EK truss2D, and then yeah, let's just put some random number in from 0, 0 to 10, -4. And then with the area of 1, and then with the E of 10,000. Done. Okay. That's your, come on. That's your element stiffness matrix. All right, we'll see you next time.